Hey there, year 11s and 12s. So in this video, we're going to be covering exercise 5.6, so chapter 5 from the year 12 textbook. For the year 11s, you're essentially still doing a stem and leaf plot, but it's in different chapters. So for year 11s, as I've handed out this sheet already, for the year 12 stem and leaf plot, so exercise 5.6 actually corresponds to 10.6 and specifically question 16, 17, and 18 just for the year 11s. For the year 12s, these are the questions you're going to be working on. So 1, 3, 4, 6, and 8. So let's have a look at that. We're now in unit 1 and 3, and we're going to do exercise 5.6 stem and leaf plots. So stem and leaf plot is a representation that we use normally for when we have grouped numerical data. So you should be copying this down into the notes that I've printed out. The stem and leaf plot and histogram represent the same sets of data. So remember, histogram only works for numerical data, and technically it's actually the same distribution. The only difference between the two, between a stem and leaf plot and a histogram, as you can see, so this is a histogram and then this is a stem and leaf plot, as you can see, is that you can see the individual scores. You see that? So this one, you can see there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, right? Whereas in this one, you can count the total. You can say there's 5 people from this group, so 0 to 20. You can see that there's 7 people from 20 to 30, but what you can't tell is, well, what do they get? So even though I said there are 5 people in this column here, 0 to 20, I don't actually know what those 5 data points are. Whereas over here, I can actually tell, well, those 5 data points are 10, 15, 17, 17, and 19. You see the difference? So with a stem and leaf plot, you can see the individual scores of data points, whereas a histogram, you can't see the individual data points. And even though the distribution is quite similar, so you can see it goes up between 20 and 30, there's a peak, and then it starts to drop down dramatically, especially 40 to 50, right? And same thing on a stem and leaf plot, you can see that 20s to 30s, there's a peak, and then dramatically drops from 40 to 50. So you can see the same distribution. But when is it useful to use one or the other? Well, logically, stem and leaf, it's only useful if you have less data, because you don't want to be sitting there counting 100 individual data points. That's just crazy to look at, right? But when you have a smaller number, this is quite useful because it tells you exactly what a histogram does, except you can actually tell in more finer detail. When is a histogram better? Well, if you do have 100 data points, you're probably not going to be interested in individual data, but you're more interested as an overall. So say if you had 10,000 people who sign up to a survey, you don't really care about each person's response. You care about the general response overall. So that's where a histogram is better to show data that is much larger. So here I wrote, when preparing a stem and leaf plot, it is important to try to keep the numbers in neat vertical columns. Okay, so here we've got 1 to represent 10, so the tens, so you can see the stem. 2 represents 20, 3 represents 30s, and then 4 represents 40s. So keeping a neat column, because a neat plot gives the reader an idea of the distribution of scores. If you don't keep it neat, or it's unorganized, or the distribution is not the same, as in like it's not consistent, then it's hard to read a distribution clearly. Okay, so the plot itself should look a bit like a histogram just on the side, as we can already see. Whoops, I should keep that as vertical columns highlighted. And I already described the benefit of seeing individual scores, because it means you have better accurate analyses of statistics. So for year 12s, you do need to know that fact if you're doing exams. So then when they ask you, when would you use a stem and leaf versus a histogram, or choose an appropriate graph, the reasoning is this is for smaller data, but you want accuracy. Versus, this is for larger data, and accuracy isn't too important to the actual granular detail. Okay, just keeping that in mind for mainly year 12s. Okay, I'm going to write year 12 here. All right, and now let's do some examples. So splitting stem and leaf into intervals. So sometimes the data is just so big, you can't do 10, 20, 30, 40, 50, 60, because if I did 10, 20, and then you had a data that was like 1,030, and then you had a 2,050, you don't want to be doing scales of tens, because then you've got a very long scale, like a vertical line is like 1, 2, and you've got to be writing all the way up until like 20 different rows, it just takes too long to do. 20 different rows is only actually 100 different rows. That's just too crazy to do. So when you have that, sometimes it's better to go in larger intervals or smaller intervals. So in this case here, so let's say I got 31, 35, 37, 48, 48. Okay, it's easy to classify them as use the 3 for 30s and then use the 4s for 40s, right? And then the leaf component, so that's the stem. The leaf component, well, 1 will then paired with the 3 becomes 31. 5 with the 3 becomes 35. And then 7 with the 3 becomes 37, right? So what if I change this distribution? Because at the moment it kind of looks like that, right? That's the distribution. What if I want to represent them in class intervals of 5 instead? So instead of 10, 20, 30, what if I wanted to go 10, 15, 20, 25, 30, 35, etc.? So how do you do that stem and leaf plot there? So with the same data, if we were to go from 30 to 35, and then 35 to 40, and then 40 to 45, etc. So what you can see here is that you can split it up by using a star. So I could do stem and write leaf. And I say 3 represents 30s. So right now I've got 31. And then let's say as soon as it hits exactly 35, I start over here. So I do a 3 with a star. So this tells people now, and you have to tell them intervals of 5 as well. Or you can do the star here so that people know that you are going to cut it off as soon as you hit 5. Okay, so you can do 3 star vertical line 5, and that just means 35, whilst this is 3/1 equals 31. So people know that the line cuts right at intervals of 5. Okay, so that's one way of doing it. So again, so if I want to go to 40, then it'll be 4 for 40s, and then so I got 48. Actually, 48 passes that. So there'll be star and then 48. So then people know that this is distinctively saying it's from 45 onwards, and that's why this is 48 over here. Okay, so then you get a slightly different distribution so that you can see clearly the numbers. Actually, it's not even pick, it's like this. Like that. Okay, all right. Let's have a look at this example over here. So if we were to organize this data where you've got 11, 12, 12, 13 into a stem and leaf plot, and they want intervals of 5. So you can see here, I'll start off with 1 to 15. But as soon as I hit 15, you start a new row. And you can see I'm doing 1 with a star there. So that means 11. I'm going to put a 1 here for 11. 2 for 12. And I got 2 of them. So 2 2s. 1 3 for 13. 1 4 for 14. But as soon as I hit a 5, I do a new row. Okay, so with a new row, there'll be 1 with a star or asterisk, and then the 5 represents now 15. Then you have 17. Then you have 18. So that ticks off these ones, 15, 17, 18. But then now there's 21. And so if it's 21, we start on a new row. So we start off with 2. And because it's 1, so it means 21. And then we have 22. But remember, it's intervals of 5. So this is now 2 star. Once you pass 25, we're on to now 26, 26, so 2 6s, and then 127 and 129. There you go. So that's how you do the class intervals. You use an asterisk depending on if they want in intervals of 3, 5, 10s, or whatever it is. You can use that to split up the data points. Okay. All right, which I wrote here. So we use 1 with a star to represent the split interval we want. All right, here's our last two examples. Now, I can pause this video, or you can pause this video and then have a go with this example, or you can continue watching from this point. So here in example 1, I'm assuming you did pause the video and you had to go first, but if you're just watching all the way through, so here we go. Example 1, you've got the following data. It represents the length of days to develop a habit for 20 participants. So you've got 20 people who signed up. And you want to see in the length of days, how many days before you develop a habit. So do you take 266 days to develop a habit, 268 days to develop a habit? And notice with all these examples I've done for you, I've actually organized the data from smallest to largest, which is known as ascending, ascending order. That just makes your life easier when you write out your stem and leaf. But you would have to do the ordering yourself when you're doing the questions from the textbook. So here, what am I seeing? I'm seeing 266, and I can write then my stem to be 26, okay? And then my leaf will be 6. So together, 26 with the stems as a stem and then 6 as a leaf, this tells me that's 266, okay? Notice that they want class intervals of 5. Okay, so that means as soon as I realized because that's 26, 266, this should be 226 with a star. So that means the 6 should go here. The reason why that happens is because you can go from 260 to 265. 265 is the star to 270. So this here represents 265 to 270 because we have to do class intervals of 5. Okay? And then we've got 268. So here we go. We've got 6, 8. But then by the time you hit 270, you go to the next row. So 2, 7. You've got 0, 271, 273. And then 275, you got to change rows again. So here's a 5. And then 6. And then 8. And then 9, and then 80, you got to start a new row. So 280, so you got 0, 281, so I'm ticking it all off. 281 again, 281 again, 281 again, so 4 of them. Then 282, 284, that's a lot, and then 280s. And then 285, we start new, so 28. So with a 5, 287, 288. Yes, that is correct. Okay, there you go. So now I've got my distribution. It says find the median. So remember, how many numbers do you have before? You had 20 participants. So this should count as 20 people overall. If you want to find the middle, remember to find the median, let's say of the number 4, so 1, 2, 3, 4. The median is the middle line. So if you have 4 different people, the middle between 2 and 3 represents the middle, right? So how did you get that? Well, if you notice, if you just do 4 divided by, instead of 2, because it cuts it right in the even, you want to do 4 divided by, or plus 1 divided by 2. So n plus 1 divided by 2. So taking the number of data, add 1 to it, and you get 5. So 4 plus 1 is 5 divided by 2. And if you do that in a calculator, it gets 2.5. So hence 2.5 is actually the middle of the second and third digit. Okay, so in our case, if you got 20 participants, well then you do 20 plus 1, and then you divide it by 2, you get 21 divided by 2. And hopefully you figure this out as 11.5. Or is it 10.5? Sorry, 10.5. It's 10.5 to get you 21. So what this means is the number must be in between 10th position and the 11th position. So if you counted 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and this is the 11th, so 10.5 must be there. And that should be nicely even or cut in half, because here you've got 1, 2, 3, 4, 5, 6, 7, 8, 9, and then on this side 1, 2, 3, 4. 5, 6, 7, 8, 9, 10. Wait, did I miscount or did I mistype? That shouldn't happen. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. I'm missing a data. Whoops. Oh, that's why it didn't work out. There's another number I'm missing. Ooh, let's make it up. Let's just write 288 for now. I got to fix my notes. All right. Well, if you're watching these videos, I would have fixed the notes and I would have added 288 on your sheet. So you probably don't have an issue once you receive this, but when you watch this video, you'll notice that I've added 288 to the list there. So that means I need another 8 over here. All right, so the median must be then between 280 and 281. So median is then equal to 280 plus 281 divided by 2, which we know it's 280.5. Okay, because it's in between 280 and 281. All right, what's the next one? Find the interquartile range. For those who have forgotten or don't know what the interquartile range is, the interquartile range talks about the middle of the bottom half and the middle of the top half. What's the difference between the two? Now, for some of us, that might have sounded like, what was he talking about? Well, with the data of an extra 288, remember the middle is cut right here. So this is the median. So I have the lower half. Here's my lower half. Yeah, there's 10 digits over there. There's also 10 digits, or meant to be 10 digits, over here. Okay? And so we're asking, what's the middle of this group? Now, since there are 10 items, if you divide it by 2, if you divide 10 by 2, you get exactly 5. But we know that it's actually not just 5, it's actually in the middle of the 5th and 6th. Okay, that must be the middle, because then you have 5 numbers on this side, and you also have 5 numbers on this side. So it makes sense that the middle is actually between 5 and 6, which is 5.5. We traditionally call this Q1 for quartile 1. It's the first quarter. So this is the first quarter. This is the second quarter. And then from here to the next upper half, where's the upper half? So it must be 1, 2, 3, 4, 5. So it must be in the middle of these. And this is the middle of those. Okay, so then the top half here, this is the group 3, this is group 4, and you can see it's 5.6 as quartile 3. Okay, so answering the interquartile range, we can say that quartile 3, so IQR, the upper half, okay, what's the middle of the upper half? So we can see that the middle is in between 282 and 284. So what's the middle of 282 and 284? It's literally 283. So Q3 is 283. That's Q3. Minusing Q1, which is the lower half of the bottom half data. Okay, so the middle of the lower half data. So it's clearly between 273 and 275, which tells us it's 274. That's Q1. So putting them both together, what do you get? What is 283 minus 74? 6 plus 3, that gives you 9 units apart. Okay, so your interquartile range is 9 units apart in general. Cool. All right, so this was a bit of info, especially if you've forgotten what median and interquartile range is. It's okay. I'll be going through more of this on Friday when we start doing means and medians and do 5-number summary. But this is mainly because the year 12 content is assuming that the students have learnt this from year 11. Okay. All right. So there, I've got my median. I know that the median, what's this represent? Days, length of days in order to build a habit is 50% of the time it's based on 280-ish days, roughly. Okay, if you round it up, it's 281 days versus the spread, which is 9. And what the spread describes is like how variable is it? And 9 is fairly small. Okay, obviously the smaller the better. All right, you can have a go with example 2 now. if you like. Again, I want you to try to break it apart. This is the, what does this represent? This represents 2 Year 11 maths classes that completed the same test. The total mark available was out of 100. And you can see that class 1 had 84, 90, 86, 95, 92, 71, 83, 97, 88, 100. So it's pretty good class so far. Versus class 2 got 90, 55, 48, 62, 70, 58, 100, 99, 97, 89 is their total. So clearly it seems like class 1 had generally outperformed, but how do we know? We can draw a box plot or we can draw a back-to-back stem leaf. So how do we do it? We can see that again the stem is 8s, 9s, and it doesn't, and then 7s, and there's a 10 there. So really I could probably do 7, 8, 9, 10. So these represent the stem. So as soon as I put a leaf on, it becomes 71 or 72 or whatever it is. So for class 1, we have 84. So 4 goes here. Then you have 90. So 90 there. 86. So 8, 6. 9, 5. So 9, 5. 92. Ooh, we should keep it in order. So 92. Was that it? Yeah, 71, 83, 97, 88, and 100. Okay, so that's for class 1. Whoops, 100 is down here. All right, so that's for class 1. That's the distribution. If you do it for class 2, you can see 90 has a 0, 55, which we don't have. Ooh, that's a bit awkward. So 5, we now have a 58. We also have 100, so 58's done. 99's pretty close, but it's here. 97, which we have 1. 89. What was that arrow there meaning? Oh, that's weird. Anyways, what do we have here? So we've got 92, 71, okay, 0, 9. Oh, we're doing this group. So STEM is 80. And for group Class B, any 80s? There's an 89. So that's done. 99, 97. What else do I need? And a 90. Oops, 97's over here. So 097. What else is there? So we then move on to, I probably do have to add in the extra digits. All right, let's add it down here. So we did need a 6 and a 5. So I've got 5 for 55. I've got, there's a 4 as well, 48. 7 for 70. 5, 8, so 58. 100 is 10. 99 is over here. 97, so I got another 7. I probably should put the 9 over here to be in order. And then 89, so. All right. There we go. So we've drawn a back-to-back stem and leaf plot. Just so you can see the distribution like that. Okay. That's essentially what exercise 5.6 is. Now, I know there was quite a bit of new info, especially IQR, so interquartile range, and then finding the median. That's okay. We will discuss that on Friday. Otherwise, thank you for watching the video and enjoy the class.